Howdy! Feeling confused about Elixir's process model and how to safely maintain state? You're not alone. Managing state and concurrent systems can feel like a labyrinth, but it's the core of building fault-tolerant applications. In this video, we cut through the confusion by solving the take a number exercise, showing you exactly how to use process for safe, mutable state inside an immutable language.
So what's Elixir's big secret for handling state? It all boils down to two fundamental ideas: processes and their unique addresses, which we call PIDs. First, let's break down what a process actually is.
Okay, so a process. First thing, don't think of an operating system process. That's not what we're talking about. In Elixir, a process is this incredibly lightweight, totally isolated little world. The best analogy? Think of it like a dedicated employee you've just hired. They've got their own private notebook, their state, and they don't share it with anyone. All communication has to happen by sending them messages.
And when I say lightweight, the difference is just, it's huge. I mean, look at this. An OS process is heavy and slow, an Elixir process spins up in microseconds. You can run hundreds of thousands of them on a single laptop without breaking a sweat. This is the absolute magic that makes Elixir so scalable.
Okay, so if we have all these thousands of little employees running around, how in the world do we talk to a specific one? That's where the PID comes in. It's the process identifier. Just think of it like an office number or a unique email address for your process. If you have the PID, you can send it a message. It's really that simple.
In other languages, trying to manage shared mutable state often leads to complex locking mechanisms and deadlocks. This exercise teaches you the Elixir way, encapsulating state inside a single, dedicated process and communicating with it only through explicit messages. This disciplined approach to data ensures your concurrent applications are both safe and far easier to reason about.
All right, enough theory. Let's get our hands dirty and actually start building our take a number machine. We'll kick things off with the very first step, just getting the machine started.
So right away, we have a question. How do we even create one of these isolated little worlds we've been talking about? How do we hire that first employee who's going to manage all our ticket numbers?
And the answer is a beautifully simple function, spawn. This is basically you telling Elixir, hey, please create a brand new process for me and have it run this piece of code. And what it gives you back instantly is the PID, that unique address we need to talk to it later. With just this one line, our machine is alive.
All right, we need to start the machine. The start function should spawn a new process, which remember is just a function. And it doesn't need to do anything just yet. Okay, so in our start function, we can call spawn. We're going to give it an anonymous function. Right now it's not going to do anything, so we'll just have it return OK and end.
Okay, our machine is up and running, but right now it's basically a black box. It can't do anything, it can't hear us, and it definitely can't remember anything. So this next part is crucial. We need to give it a voice and a memory.
Our next task is to ask the machine a really simple question. Hey, what number are you on? This means we need a way to send it a message and then have it reply with its current state. And to start, that state is just going to be 0. This brings up two new challenges at once, right? First, how do we actually send a message to the process we just spawned? And second, how does a process, which is really just a function, remember its state from one request to the next?
And here is the absolutely brilliant solution, the recursive receive loop. Here's how it works. Our process sits inside a receive block, which is like its own personal inbox. It just waits. When a message, like Celia reports state, sender, shows up, it pattern matches on it, sends a reply back to the sender's PID, and then, and this is the most important part, it calls itself again with the exact same state. That recursion is what gives the process its memory and lets it wait for the next message.
Step 2 is the very biggest bite of this exercise. We're going to need to have a receive loop with an initial state of 0. And that loop, remember, is going to call itself, so it needs to be a named function. So let's go into our take a number, and let's define that function first. It'll be def, we're going to call it loop, the P is for private. We'll have an argument of state. Then up here in our spawn, we can call loop with the initial value of 0. All right, so what does loop need to do? It needs to receive a message. The syntax of receive is very much like a case statement, with the exception that you're pattern matching against the message that was received. Well, boy, it's going to try and finish this whole thing for us, so let me accept it and then get rid of it. All right, so for this step, we simply need to receive the report state message, send back to the caller the current state. The receive loop is like a cashier who serves one customer, then immediately calls the next customer while holding their money safely in the till.
Awesome. Our machine can now tell us what number it's on. So let's teach it its main job, handing out new numbers. This is the first time our process is going to need to actually change its state.
The pattern is almost exactly the same, but with one critical little difference. When our process gets a take a number sender message, it first calculates the new state by adding 1. Then it sends that new number back. But look closely at the very last part. It calls the loop again, but this time it passes in the new state. And that's it. That is how you manage state in Elixir. You don't change a variable, you just pass an updated value into the next function call.
Step 3 is to respond to the take a number message, increase our state by 1, and send that new state back. All right, so when we get take a number and a sender's PID, we're going to take whatever our current state is, add 1, we're going to send that back to the sender, and then we're going to loop on ourselves with the new state. Elixir's preference for recursion is heavily influenced by the Erlang virtual machine's tail call optimization, which allows recursive functions that call themselves as their final action to execute without consuming additional stack space. This practice would cause stack overflows in many other languages, but in Elixir you can write elegant recursive algorithms enabling robust, long-running processes without performance penalties.
Our process works. It can report its state, it can change its state, but it's a little fragile, you know? So now we need to add that professional polish. We need to teach it how to shut down cleanly and how to handle messages it doesn't understand.
Every good machine needs an off switch. So our next challenge is to give ourselves a way to tell the process, okay, you're done for the day, and have it shut down gracefully.
So how do we break out of that recursive loop we just built? It seems like it would just go on forever, right? Well, the solution is actually surprisingly simple.
We just add another clause to our receive block. When it gets the simple message, stop, it just stops. Notice what's missing. It doesn't make the recursive call back to the loop function. So the function just finishes its job, and when the function is done, the process exits cleanly. That's all there is to it.
Step 4 is stopping the machine. When we receive a stop message, we should stop our looping. So here we will look for the message matching stop. When we receive it, we'll just say OK and not call loop again. Did you know that with a little planning you can deploy new versions of your Elixir code without ever stopping the running system? This feature, known as hot code swapping, is inherited from Erlang's battle-tested runtime and lets you patch critical production applications instantly, maintaining a stateful service with zero downtime.
Okay, one last thing. What happens if someone sends our machine a message it doesn't recognize? As it is right now, it would crash. We need to make it a little more resilient. And this is just a beautiful, classic piece of idiomatic Elixir. We add a catch-all clause at the very end of our receive block using the underscore. This pattern will match anything. So if a message comes in that doesn't match our other, more specific clauses, it hits this one. And all it does is ignore the message and call the loop again with the same unchanged state. This makes our process incredibly robust.
And the catch-all step. So if we receive a message that doesn't match any of the above patterns, we should just ignore it and then wait for the next message. So in our pattern match here, we use underscore to say we don't really want to bind what the match was. And And what we want to do is loop with our current state.
Let's recap what we learned. We saw that processes give us perfect built-in state isolation. We learned how to create a persistent server using a simple recursive loop. We saw the magic of handling state not by changing it, but by passing a new version into the next loop. And finally, we used Elixir's awesome pattern matching to define all the behavior and make it bulletproof.
You've successfully built a stateful machine, which is a significant step towards Elixir proficiency and understanding how to manage state without mutation. The core takeaway here is that isolated processes plus explicit message passing is your roadmap to safe concurrency and fault tolerance. This pattern prepares you for more advanced topics ahead, like the Gen server. Send a message to YouTube saying you liked the video or learned something today by hitting the like button. Subscribe so you don't miss out on more accelerated AI-guided walkthroughs that deconstruct Elixir challenges like this one. Dive into the playlist to continue building your expertise one powerful function at a time. See you next time.